Hello, Sanvi.
Hello, sir.
Good evening. Actually, I was
Good
having one
evening.
more class back to backs, and that class got extended for
Oh,
five
okay,
minutes. So
sir.
that's why. So, so these are the three questions.
Sir, I completed the first two, but you said you'd explain the last one.
Yes. So now see the first and second. You are done with this.
Yes, sir.
So for the last one, what I told you, like we are having two things here: a square root as well as log.
Yes,
So
sir.
for a square root to be defined, the thing inside the square root, the thing inside the square root, not a square root. The thing inside the square root is your x square plus 5x minus 6 greater than equals to 0. And then
Yes, sir.
for log to be defined, the argument of the log has to be greater than 0.
Greater than zero.
Now individually you solve these two identities and we have taken the same thing here. So you change this, no? Oh, no, it's not the same. So now tell me, just think like these are the two different questions. You tell me separate answer for this, separate answer for this. And then I will
Okay, sir.
explain how we can merge the answers together.
Sir, the first one is, I got the first one already because that's the first question.
Okay, what is the answer for this?
Um, Negative infinite to negative 6.
Negative 6 union
Union 1 to positive infinite.
x equals to. Now,
Yes,
second part you solve.
yes, sir. Could you give me a second, sir? I'll go get my
Yes,
book.
yes, yes.
Sir, I got it. It's negative infinite to 2.
Both
Union.
closed, right?
Yes, sir.
Both open.
Both
Union.
of. Yes, sir. 3 to infinite.
Now see, if overall fx has to be defined, then a square root should also be defined. Log should also be
Yes.
defined.
Yes, sir.
Means both has to be defined. So the common part, we have to look for the common part. Why? Because both has to be defined. So both will be defined only in the common part. So how to realize that? So look, you can just draw the number line. You can mark the points. What are the points? It's -6, 1, 2, 3.
Yes, sir.
-6, 1, 2, 3. So -6 means, let us say here it's -6. Then we have 1. Then we have 2. Then we have 3, right? Now the first part says that the answer should be your from negative infinite to -6. And then 1 to infinite. That is the answer for the first part. Second part tells you that answer has to be from negative infinite to 2 and then from 3 to infinite, right?
Yes, sir.
Now we have to look for the common. So that's why I have used different color. Red color represents the definition for first part. The blue color represents the definition for the second part. Now you
Yes, sir.
have to look for the portion where you can see both the colors, blue as well as red. So see, this part, in this part, we have both the colors blue as well as red, right?
Yes, sir.
But in this part, we do have blue, means the second part, that is log, is defined, but the first part, square root, is not defined. So that
Yes, sir.
cannot be overall the answer. Then again, from 1 to 2, we have both the colors, right? Means both
Yes,
are
sir.
defined. Between 2 and 3, look, the red part, that is first part, square root is defined, but log is not defined. Then from 3 to infinite, again, both is defined. So in
Yes,
parts, negative infinite to -6. Now whether we should be taking -6 in open or closed. So for that, you go and check the separate answer here. 6 is in closed, right? Means
yes,
at 6, the square root is defined. At 6, see here it's continuous line, means at 6, the log is also defined. So 6 has to be taken in closed interval. Then 1 to 2, so union. Now for 1 to 2, close or open. So look, at 1, for 1, the square root is in closed. But what about the log? So see, at 1, log is also defined, no, because here it's continuous line.
yes,
So
sir.
1 has to be in closed.
Closed.
But
And 2
at
has to
2,
be on open, sir.
open. Look, for 2, a square root you can, for a square root function, 2 is there as the part of the answer. But for log, 2 is not there, right? So 2 has to be in open. Union. Similarly, for a square root, you can
3,
take the 3, but for log, 3 has to be taken in open interval, right?
yes, sir.
3 to an infinite and negative infinite, we always take in open.
Open, yes, sir.
That is the answer. Now see, we have a question. Y equals to log of 1 by 2 log of x square minus 4. Can you try this question?
Sir, do you mind
Mhm.
explaining it first?
Look, actually, don't think about log much. In log, we are going to have two things. Some number will be here that we call as argument, and some number you will have here downward that we call as base. And here it's argument. So here actually we are having two logs. For the first log, what is the argument? This complete thing is the argument for the first log.
Yes, sir.
And for the second log, what is the argument? X square minus 4 is the argument for the second log. So both the arguments. For the first log, what is the argument? So for the first log, log of x square minus 4 is the argument, right? So this has to be what? Argument always has to be greater than 0.
0. Yes,
Now for the second log, what is the argument? X square minus 4. So x square minus 4 should always be greater than 0.
0.
Now I will be discussing the basic things about the log, but one thing you always keep in mind. And look, here we have taken the base as 1 by 2. You can take any base, just keep the base as simple, like let us say base is 5. So always keep in mind in the log, whenever argument becomes 1, then whatever may be the value of the base, the answer for this complete thing is 0. So 0 can be written as log argument 1 with any base. Getting this?
Yes, sir.
So now you tell me the answer for this part, and this part you look what we are going to do here. X square minus 4 and 0 can be written as log of 1. And actually when the base here is given to you as 5, and for this log also you take some base, like here also you take here as 5 only. It means here we have 5, here we have 5, and here with when you take argument as 1, you are free to take any base. For any base, when argument is 1, it becomes 0. So here also we can take the base as 5, right? Now we can remove the log because we have log on both the sides. So directly we can compare the arguments. We can say x square minus 4 will be greater than what? 1. So look, you get x square minus 4 greater than 1. And then you have to solve for x square minus 4 greater than 0. 1 you can take on this side. So you get x square minus 5 greater than 0. And x square minus 4 greater than 0. Solve this two and combine that. Combining means look for the common part. Because both has to be defined. The second log also has to be defined. The first log also has to be defined.
Yes, sir. Sir, for the first one, it's negative infinite to negative square root 5.
And then positive square root 5 up to
Uh, Positive infinite.
finite. For the second part, it's
Uh, it's negative infinite to negative 2.
so again the four numbers. So you try to combine this, no? You take one number line. Look, the only thing is that you need to realize that here, if we assume here as negative root 5, and here we take as, look, negative number on the left, positive on the right. Now, where you will
Yes.
have the number negative 2 and positive 2? Will it be on this side or this side? That is what you need to realize here. That's it.
Yes.
So, where you will have the number negative 2 and positive 2.
Uh, just 1 second, sir. Sir, negative square root of 5 is minus 2.24.
So, just tell me, no, as compared with negative root 5, negative root 2 is going to be on the left side or right side?
Sir, it's
Because
gonna
this is
be.
number, yes,
Yes, sir, what were you saying?
on this number line, we have already taken the number negative root 5, right? Now, on the
Yes.
same number line, if you have to write negative 2, where you
Uh,
will have this negative 2
it's
on the
gonna
left,
be to the right side.
right side. So, somewhere here we can mark the number negative 2.
Yes,
Where you
sir.
will have positive 2.
Yes, sir. 1 second. It's gonna be before to the left
Yes,
hand. Yes, sir.
positive 2. Now, the first part, for the first part, the answer is from negative infinite to root 5. So root 5 to infinite. And both in open. Open means you better draw hollow circle here, right?
Yes, sir.
For second part, the answer will be from negative infinite to negative 2 and 2 to infinite. Both open, no?
Yes, sir.
Hollow circle. Now, what is the common part that we have here? So the
Sir,
common part,
the part between 2 and no, from 5 to negative root 5 to
negative infinite to root 5, negative root 5.
yes, sir,
And then
and root
positive
5
root
to
2
positive infinite.
means whatever the answer you get for this part. And look, it's quite obvious, no? This
Yes,
part is actually you are solving for x square greater than 5. If the square of a number, that is x square, is greater than 5, then obviously x square will be greater than 4 also. Because if something is greater than 5 means obviously it is greater than 4 also. So this second part is already included in the first part. So this first part answer is simply the final answer, right? So x
yes,
is
sir.
going to be your negative infinite to negative root 5 union root 5 to infinite. Everything in open bracket, right? Open interval.
Yes, sir.
Now let us say y or fx equals to log of now actually what we can realize here that okay, argument as well as base in both we have x. In the previous question that we solved, base was given to you as some fixed number. So we do not bother about that. 5, that is already greater than 0. 5 not equals to 1. Here also in this question also, no? Like log is there, no base is given means we are given with some, look, generally if no base is given, we assume the base as E. Okay. But when base is given, then you cannot assume this as anything else. So here base is given to you as x minus 4. Argument, there also we have x. So the complete argument we write greater than 0. Base also we write greater than 0, and also we write one more thing. Base should not be equal to 1. Are you getting this?
Yes, sir.
And just replace this with 3. Solve this question.
Yes, sir. Sir, it's
Hmm.
negative infinite to 2.
Oh, look, first we write the argument greater than 0. So x square negative 7x plus 10 greater than 0. Then we write base also should be greater than 0. No, what is the base? X minus 3 greater than 0. Then we
Yes.
write base should not be 1 also. So x minus 3 should not be 1. So x minus 3 should not be 1. So from here we get the answer alike. Okay, x should not be equals to, and okay, should not be equals to how much? 4. Here we get simply x has to be greater than 3. When it says that, okay, the value of x has to be greater than 3, how you are telling me the answer from negative infinite? Because you will have to consider this also, right?
Yes, sir. I was talking about the first part, sir.
No, you just solve all and you have to merge them together and you have to give me the final answer.
Okay, sir. Sir, it's 5 to infinite.
And here you will get this minus 2 and 5. So here we get x as negative infinite to 2, union 5 to infinite, right?
Yes, sir.
And when we merge this together, no? So x has to be greater than 3.
Yes, sir.
So just try to merge this. X has to be greater than 3 means obviously this negative thing. Look, you will be having the number 2 somewhere, like let us say here we have the number 2. Here we have the number 3. After that we have the number 5. X greater than 3 means like this. Closed, not closed, open one. But between 3 and 5, somewhere you will be having the number 4, and that cannot be the part of the answer. So above the 4, you have to take a hollow circle here, right?
Yes, sir.
Then minus negative infinite to 2, and then 5 to infinite. So yes, the common part is simply the 5 to
5
infinite,
to
right?
infinite. Yes, sir.
Yes. X has to be 5 to infinite. Try this.
Um, Sir, we actually haven't done the x cubes yet.
Okay. But you know the interesting thing,
Yes, sir.
I intentionally give you, look, I can give you here the power 30 also. Then also the solution remains the same. Actually, see, in the numerator, we have just a polynomial. We have polynomial, and always keep in mind polynomials are defined for all values of x. Now, what do you mean by polynomial? Means the variables having whole numbers as the powers, right? So if I simply give you the question, like separate question, y equals to x power 30 plus x square plus 5. What is the domain for this? You will say, sir, this is a polynomial. It's always defined. So here the domain is simply going to be from negative infinite to positive infinite. So for polynomial kind of expressions, no, you have to do nothing. So you don't have to bother about this. Okay, here it could be anything from negative infinite to positive infinite.
Yes, sir.
Restrictions you will be getting from the denominator. Why? Because in denominator we are having two things. The first is a square root. So within the square root, whatever you have, that has to be greater than equals to 0. But since the square root is there in the denominator, so okay, you can write like this, x square minus 5x plus 8. You can say, sir, this has to be greater than equals to 0. But then you will say, sir, The square root, the complete square root is in the denominator. So this should not be 0. If this should not be 0, it means x square minus 5x plus 8 should not be 0.
Yes,
It
sir.
means what? It means here you have taken equality to 0. You don't have to take here equal to 0. It has to be simply greater than 0.
Yes, sir.
Now the problematic thing is, can you solve this? That is the main challenge. So look, whenever we have a square root, but that is in denominator, so this expression now can't be equal to 0 also, because when it becomes 0, overall denominator becomes 0, it's undefined. So here you don't have
Yes.
to take equality sign, simply you need to solve for this.
Yes, sir. Sir, I didn't get the right answer. I'm not able to figure it out. Can you help me?
You know one thing, the discriminant of a quadratic, d square
Yes,
minus
sir.
4. Tell me how much is the discriminant here.
Okay, yes, sir. Sir, it's 7/4.
Discriminant means b square minus 4ac.
Oh, uh, yes, sir. I divided it by 4. Yeah.
No, that is the that we are not finding here minimum or maximum value, just the value of the discriminant.
Yes, sir. It's -7, sir.
Yes, so whenever we get the discriminant as -7, negative discriminant means we are going to have no roots here. The roots are imaginary, right?
Yes.
So just let's try to discuss this basic thing. Look, sine scheme, this we also call as sine scheme of any given expression. So how we get to know the sine scheme? Sine scheme means what? We are going to discuss quadratic. Let a quadratic expression quadratic function fx as ax square plus bx plus c. Here,
Yes, sir.
the value of discriminant is given by b square minus 4ac. Now we have to solve. What happens? Sometimes we have to solve the given quadratic for greater than 0. Sometimes we have to solve for lesser than 0, right? So in
Yes.
both the cases, actually discriminant plays an important role. So the first case says that if the value of t is negative, less than 0, then the sign of fx means the complete quadratic. Sign of fx is same as the sign of a. Now, what does it means? A is the coefficient of x square. So try to understand with the x square negative 5x plus 8. And let us say we have to solve this for greater than 0. Or let us say we have to solve the same question for less than 0. Okay. So see, both the answers we can get in one go. So first we calculated here the discriminant. You told me the discriminant is -7, that is negative, right? Now, what
Yes,
is the value of a here? In both the value of a is how much? 1, right? 1 means it's positive 1, right?
yes, sir.
Now, what do you mean by this statement? When d negative, fx means the complete quadratic. That is x
Yes, sir.
square minus 5x plus 8 will have the same sign as of the sign of a. Look, we are discussing the sign only. We are not discussing about what will be the value. When we say it will have the same sign as of a, so here a is having positive sign. It means this x square minus 5x plus 8 will have positive sign always.
Yes, sir.
It's always. You can check this in x square negative 5x positive 8. Whatever you are willing to put here, you put x as 5, minus 5, 10, minus 10, 100, 1000, 0, anything. This expression will give you some positive value. You can check this. Put 0, you get, if you put here 0, see, you get 8. Put 1. So 1 minus 5 plus 8, see, again we get positive. Put -1. -1 whole square 1. -5 into -1 plus 5 plus 8, see, always we get positive. It means for all the values of x, the expression is going to be always positive. When
Yes,
it's
sir.
always positive means it will not be negative. It can never be negative. So for the complete number line, this expression is going to take the positive value. Nowhere it will be taking the negative value. Now, what does it mean? It means that if you have to solve for greater than 0, that is for positive, then your answer is going to be from negative infinite to positive infinite. And if you have to solve for less than 0, so as I told you, nowhere it is going to be negative. So for that, the answer is simply going to be no answer you get in X. Means X we call as phi. Actually, phi is actually the set that we call as void set, in which we don't have any element. So X writing like this, or sometimes we also write X as two braces, but nothing inside it. So that represents the void set. Phi is the symbol for that. And the solution for the first part means for this, the solution is going to be from negative infinite to positive infinite. And always keep in mind, from negative infinite to positive infinite, this we also represent by capital R, the set of real numbers. The set of real numbers. So in the given question, we have to solve for greater than 0. So you get X can be from negative infinite to positive infinite, right? So see, D negative. So this expression will have the same sign as of the sign of A. A here is +1, the coefficient of X square. It means this expression will always be positive. So if you have to solve for this, you will simply say the X here is going to be real. Means this thing inside the square root is always going to be positive.
Yes, sir.
That is the only thing that we need to solve for. For numerator, we already have the same value like numerator. We can have X as anything. For denominator also, you can have X as anything. So overall, the X could be anything. That is, finally, this is the answer. Got it?
Yes, sir.
This is the final answer. But discriminant sometimes, and look one thing, X square minus 5X plus 8. D negative means the sign will be either always positive or always negative.
Yes, sir.
If the coefficient of X square is negative, like let us say negative X square is there. In that case, yes, you can have the sign always negative, nowhere positive. Always keep in mind when D is negative, no, the quadratic expression will either be always positive or it will either be always negative. We cannot have the two situations, like somewhere it's positive, somewhere it's negative.
Negative. Yes.
Now in negative or positive, what is the actual value that we get? That we don't have to bother about, right? It can be positive 5, positive 50, positive 500. That is not the concern. Clear?
Yes, sir.
But for the second case, if discriminant is 0, and actually when D is negative, no, we are not going to have any roots. But actually when D is 0, in this case, then we have equal roots, right?
Yes, sir.
Now, for example, let us say we have the question like X square minus 2X plus 1. We have to solve for less than 0. And when we are taking some negative sign also, like this time we take the expression having negative coefficient, like let us say negative X square, positive 4X, minus 4 greater than 0. And the same thing we have to solve for less than 0. If you see carefully, no, here the discriminant, you check the discriminant B square minus 4AC, it's going to be 0. Discriminant being 0 means it can be written as whole square of something. So see carefully, this is going to be your You can solve this. You can take the negative common. So I think it's x minus 2 whole square with negative sign, right? So if you simplify, the root for this is going to be simply x equals to 2, right?
Yes, sir.
Now, in this case, rule is almost the same as of the previous rule, but only one difference is there. In previous case, the given expression can't even be equal to 0. Either it will be always positive or it will be always negative. But in this case, yes, it can be 0 for one particular situation when the value of x equals to the root of this equation.
Yes.
Somewhere we have 2 on the number line. So for 2, the value of the expression is going to be 0. But for rest of the values of x, now the sign remains same as the sign of a. So here also, sign of quadratic that we generally take as ax square plus bx plus c is same as sign of a. Now see here, for this, a means it's minus 1, right? So for all the values of x, minus 1 means it's negative, no? So for all the values of x except this value 2. Because at 2 it's going to be 0. For rest of the values of x, it's going to be negative always. So when we say it's going to be negative, means nowhere it can be positive. Are you getting this?
Yes, sir.
So here also it will either be always positive or always negative except for the one value where, now see, when it's always negative, then for one value of x, it not becomes positive, actually it becomes 0 for that part, right?
Yes.
So it depends. Let us say I give you equality sign here. If with 0 you have the equality sign, it means you have to solve for 0 as well as positive. So can you just tell me the answer here? If it's always negative, so for the first part we have to solve for positive. You will say nowhere it is positive. So for the first part, the answer is simply going to be x as this we read out as 5. 5 means what set? No value of x, no answer. For the second part, now here you should not say x equals to r. Because with 0 we haven't equality sign. If here we have the equality sign, then we have to solve for 0 and negative. So in that case, we can say, okay, x could be real number. Because at 2 it's 0. For rest of the points it's negative. But since we don't have equality sign here, means you don't have to solve for equal to 0. You have to solve for negative. So here you will say, okay, x could be. So look, there are two different ways to write the solution. Either you write negative infinite up to 2, take 2 in the open, and then you take 2 to infinite. In both the intervals, 2 you have taken in open means that 2 is excluded. Or the same thing we can write like, you take everything from negative infinite to positive infinite. That is the set of real numbers. And from that set, you just delete or subtract one particular value, that is 2. So see, this is the answer for the second part. Got it?
Yes, sir.
We don't have to use here interval because only one value has to be deleted from the real number, set of real number. But if I
Yes.
give here the equality sign, simply the answer is x equals to r. Clear?
Yes, sir.
Now we have one more situation when discriminant is actually positive. And most of those questions that we solved, that was for D positive, where we get two roots, right?
Yes, sir.
But anyway, let me write this. If D is positive, means you are going to have two different roots. Or like, for example, you can take like x square, negative, or let us say positive 7x, positive 10. We have to solve this for greater than 0. We have to solve the same for less than 0. So here, okay, we know we are going to have two roots. We factorize this, we get x plus 2 times x plus 5, right? The roots we get as -2 and -5. Here, in this case, it's quite easy. You just have to write down the two roots, and look, when we write the numbers on the number line, on the left we take the smaller number, on the right we take the bigger number. So order you have to maintain, right? From left to right, smaller to bigger. So somewhere you will have, so on the left we can take -2, and here we can take -5. Yes or no?
Yes, sir.
Think about it. -5 is a smaller number. That has to be written on the left. -2 is bigger as compared to -5. So on the number line, this is not the right sequence. -5 will be on the left
Yes, sir.
and -2 will be on the right. So that's why, let us say this expression is fx, and roots for this expression we assume as alpha and beta. So we have to represent alpha and beta in order, like a smaller has to be written on the left, bigger on the right. And then what is the rule? Between beta and infinite, you will have to take the same sign as of A. Look, I tell you same sign. I don't tell you like it has to be always positive. Because most of the examples we are taking where A is positive. But yes, A can be negative also. So in that case, the A becomes -1, it is having negative sign. So between -2 and infinite, now we will have to take negative sign actually, right? So when we say same sign as of A, so it depends on A, whether A is positive or negative. Again, between negative infinite and -5, same sign as of A. But between alpha and beta, we take opposite sign. Of A. So here we have A. That is 1, that is positive. So here we take positive sign from -2 to infinite.
Infinite.
Here again we take positive sign, and here we take the
Negative sign.
negative sign. And look, we have to solve for the first part, that is greater than 0. And here we haven't taken equality sign. Look, if we take the equality sign, means end point has to be taken in closed interval. We don't have
Yes.
equality sign, means that has to be taken in open interval.
Open interval, yes.
So here the answer for greater than 0 is going to be x equals to negative infinite to -5, open interval union, -2 to infinite, right? But for this part, your answer is negative. Less than 0 means negative. So here x is going to be from -5 to -2 in the open interval, right? Clear?
Yes, sir.
So we have one more thing. I will explain that in the next class. Now we will be having not only the quadratic, we will be having some expression in numerator, like x minus 2, x plus 3, then x minus 5, power 3, like this. And similar kind of factors we will be having in denominator. So you remember, rational numbers are some integer in the numerator, some integer in the denominator. So here some polynomial in the numerator, some in the denominator, that we call as rational function. What? Rational function.
Yes, sir.
So we will see if you can handle the rational function from there itself, you can handle quadratic as well. For those quadratics for which the roots are real and distinct, like when discriminant is
Yes.
positive. So if you can handle the rational functions, means you can handle everything.
Yes, sir, but we don't have this in school right now, and I was hoping we could do binomial expansion.
Okay, so okay, that's all for today, right?
Yes, sir.
So we'll start with the binomial. Just check with your teacher if we have to solve actually range. Actually, we solve all those questions that were for domain. Range is also there. So you can just check out. Otherwise, I can start the binomial theorem. Okay.
Yes, sir.
But you just check if we have to solve for range, and in most of the cases we are doing that range questions. But you just check and let me know in the next class. Accordingly, we can either start the binomial or we can take one more class for the function, right?
Yes, sir.
That's all for today. Isika is Anvi. So I'm closing the class for the day, right?
Yes, sir.
Bye.
Bye, sir.